Opposite, not all calculators have this feature, however. Press enter and we get 0.2023. All these calculations that we performed by hand. Thank you. Thank you very much. Now, thank you very much. Next, so when I want to determine, this is part B, what is the probability of obtaining fewer than 3 households based on a random sample of 20 households? Okay, now fewer than 3 will mean the probability for x equals 0 plus the probability for x equals 1 plus the probability for x to be 2. It will calculate all these and will add them up. Okay, so this time, second in distributions, of course I should have thought of looking there. We are going to use probability Cdf Cumulative, because this time we want the calculator to add 3 different probabilities. So let's see. Trials 20, probability 0.25, and the value should be written as 2. And the calculator, these are the new calculators. I haven't tried this. I'm gonna check just to make sure that that's the syntax. So it will calculate, because it's the cumulative distribution, from the lowest till where you tell it to stop, including x equals 2. And we're gonna check in a minute, right? So it will calculate the probability for x equals 0, x equals 1, and x equals 2, and I press enter, and I get 0.09126. Since I don't trust it, I have to do this by hand just to convince myself, only because I have not used this particular calculator, and I just want to make sure that it calculates all 3. So trials 20, probability 0.25, and the x value 0, and I want to determine that. Nope. I don't want the normal, I want the binomial. Okay, so that's correct. Good. So the first one is 0.003171. And the next one I'm just going to add. I don't have to put them in. Write them by each and every one of them. So now I want 1. And now I want plus. I don't have to write them down. Plus PDF for 3. Oh no, of course for 2. Good. And now I want to calculate. Okay, now I'm convinced that the calculator is doing the right thing, or I know the correct syntax. So it is correct. So when you use the probability, so binomial PDF, this is for one value only. When you determine binomial CDF, it's from left to where you wanted it to stop, to where we want to stop, inclusively. So the probability for x to be less than 3, I had to stop at 2 if I use the calculator. Now if I want less than or equal to 3, then I will stop at 3. I will have 0, 1, 2, and 3. Okay, this was part B. Now let's move on to part C. What is the probability of obtaining at least 3? Okay, the probability for x to be greater than at least 3. Wireless only households based on a random sample of 20. Okay, that will mean 1 minus the probability for x to be less than 3. Careful, the CDF will not calculate this. It's from left to where you wanted it to stop, not from 3 to where you wanted it to go. So careful. This we already have. We calculated in part B. So this is 1 minus 0.09126. That's all we need to write. 1 minus 0.09126. So the probability is 0.90874. Okay, and last one. What is the probability of obtaining between 5 and 7? So the probability for 5, 7. Based on a random sample of 20. Okay, careful with this one, because for the calculator, we have to write P less than or equal to 4. Let me explain and then I'll come back to this. So we have between 0, 1, 2, dot, dot, dot. I'm going to put 5, 6, 7, dot, 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 20. So we are only interested in this piece. The probability for 5, 6, or 7. In order to determine the probability for 5, 6, and 7, I will calculate the probability for 7 and subtract the probability for 4. So 7 here, minus the probability for x less than or equal to 4. In order to include 7, so I will have the entire probability, including 7, but I have to subtract what I don't need. I don't need the probability for 0 to 4. Why I need to use this? Because of the probability of CDF. It needs to start from the leftmost point. So from this one will calculate the probability between 0 and 7, and this one will calculate the probability between 0 and 4. When I subtract them, I get this probability. Ready? Second distributions, go back to probability CDF. Press enter. Number of trials 20. Probability still 0.25 for a success. X value now is 7. And yes, I want to paste. And then subtract. Second and distributions. Go back to the probability of CDF. And yes, but that's 4 now. And paste. So I have this probability minus this probability, and I press enter. And I get 0.4833. 0.4833. Finally, compute the mean and the standard deviation. That is no problem whatsoever, because the mean of the binomial random variable is NP. Very nice. And the standard deviation for this variable is the square root of NPQ. So this will be 20 multiplied by 0.25, and this will be the square root of 20 multiplied by 0.25 multiplied by 0.75. So 20 times 0.25, and it's 5. And the square root of, I always like parentheses in there, 20 multiplied by 0.25 multiplied by 0.75, and I get 1.9365. That's the standard deviation and the mean for this variable. I want to go back to StatCrunch for a second to see how we do this for a binomial. So I'm looking again. I want calculations. Yes, that's where it is. And I want binomial right here at the top. So one more time, we go to Stat, Calculators, go across to Binomial, select Binomial, and we put n equals 20. Where's my keyboard? So let's select n equals 20, and the probability is 0.25, and we are checking all our answers now with StatCrunch. What was the first one? It was 5, wasn't it? Yes. So click, make sure that you put the equal symbol for 5. Look how now, what type of distribution does this appear to be? Quite what? I would say quite bell-shaped. And compute, it doesn't have to compute, we already have the answer here, and that's exactly what we obtained. Okay, that was part A. Part B, we want less than 3 in part B. Careful, select less than and put 3 and compute. And we got 0.09126. Okay, I'm checking part C. Part C was greater than or equal to 3. StatCrunch can do that. The calculator cannot. So we compute, it's already there, 0.90874. Now, we want in between. So we'll click on in between, and this time we want between 5 and 7. So between 5 and 7, and compute, and we got, where was our answer? We got 0.4833, correct. And let me see if we can get the calculator, the StatCrunch to create the mean, determine for us the mean and the standard deviation. Can it do that? Do I have an option? No, I don't have an option. Let me look at options. What options are there? And no. Okay, well, I guess it's anyway, it's too easy. It's NP and the square root of NPQ. Okay, last thing I would like to look at, and I will stop so we can look at the quiz. It's on page 4. I would like us to, we already looked at histograms. See how nice it's already showing you that it's selecting 5, 6, and 7. That's really nice. So back to binomials, calculators and binomial. And this time I would like to create this distribution with 10.2. It's the last example on page 4. And I don't want to compute anything. I just want the calculator to give us the histogram, and it did. Now, see, in part B, we have n equals 10, but the probability is 0.5. Notice what happened. So let's go back to 0.2. And I would like you to tell me what you notice. So this was with 0.2. And now the same thing, but with 0.5. I see what happened. Thank you. And now we increase the probability to 0.8. Let's see what happens this time. So can anyone say one sentence about the comment on the shape of the distribution? So when the probability for the same number of trials, the probability was 0.2, it was skewed to the right. When the probability was 0.5, was kind of nicely bell-shaped. And when the probability of a success went to 0.8, it appeared to be skewed to the left.